Hi everyone, welcome to my channel, Math Made Easy with Terry in 10 minutes. So we're gonna go straight into this, finding area of the curve entirely above the x-axis. I'm gonna introduce the concept here, maybe one example. In another video in the part 2 of this, I'm going to solve more examples as well. Before I start, please make sure you review previous videos, okay? It's very important you do so. And if you've not liked, shared, and subscribed, I don't know what you're waiting for. Don't forget to click the notification bell so that when I post new videos, you'll be the first person to know. All right, so how do you find area under the curve? I gave a brief overview in the previous video, so please go back and have a look at it. And here, there's one thing I need you to always remember, that the area under the curve is from that curve or line to the x-axis. It does not matter where it is. It's from that curve or line to the x-axis. So that's why it's called under the curve. Does that make sense? So I'm going to write it here. So always remember, all right, that the area is under the curve. So the key word here is under. All right, it's under the curve. In some cases, it could be the line. So it could be a line. It does not really matter. From that line to the x-axis. So always remember, it's from the line of the curve to the x-axis. Okay? And another thing again is that usually in the exam, drawing a curve is not important, or it's not compulsory, but important. Let me put it that way. So usually I always advise students is, if you have an opportunity, try to sketch the curve so that at least you can have a visual representation of what you're looking for. So drawing the curve to see the shaded area is not compulsory, but it's important. So I'm going to write it here as well. So these are two things I want you to keep in mind. So drawing the curve, okay, to see this shaded area. It's not compulsory, but important. Okay. So I always advise, if you have a chance, please make sure you sketch the curve, okay? So it'll be easier for you to see. All right, let's go straight to the steps, okay? So there are 5 steps here, or 5 rules, okay? For this, or let me just call it steps. So there are 5 steps so that when you're solving this. Now, the first one is that the area must be positive. So when you're solving, the area must be positive. Don't forget that. Now, what you need to know here is that even if, for instance, even if it's negative, you have to ignore the negative sign. So if, for instance, you solve it and it's negative regardless, okay, you have to then what? Ignore the negative sign. Because an area can never be what? Negative. Number 2 is that firstly, what you have to integrate the function as normal using any of the previously discussed 16 rules for integration. So it's very important before you come into area under the curve, make sure you know how to integrate, because that is the key here. That is the underlining theme that's going to apply to all the questions. So you must learn how to integrate. So firstly, all right, you have to integrate the function. Okay, as normal. So integrate the function as normal using any of the previously discussed rules. Number 3, now after you're done with that, the next thing you do is that you substitute the upper limit into the integral expression from step 2 and have a value. Let's call the value y1. Is that okay? So the next thing you do, you substitute the upper limit into the integral expression. From step 2. And have a result called, let's call the result y1. Is that okay? So let's call the result y1. So that means when you substituted the answer you get, let's call it y1. Now, number 4, you repeat the same thing with the lower limit. So you substitute the lower limit into the integral expression from step 2, and let's have a value, let's call it y2. So the next thing you do, you substitute the lower limit into the integral expression from step 2. And we're going to have a value. Let's call it have a result. Let's call this result, let's call it y2. Okay. Now, when we're done with that, number 5, then you then subtract step 4 from step 3. So that means y1 minus y2 to give an answer. So you then subtract step 4 from step 3 to give the area, all right? So that what I'm saying is that it's going to be y1 minus y2. And this is going to give us the area for that, all right? And that's how you find the area under the curve for this. All right, so let's pick one example for this video, all right? We'll pick one example, and next video, I'm gonna solve more examples, okay? So let's pick an example here. We have this example. So let's say we have, we're asked to determine, all right? We're asked to determine the area bounded by the curve okay, y is equal to 4x squared plus 7x plus 9, all right? The axis, so let's talk about the x-axis. For the x-axis, for this curve and the ordinates, okay, the x-axis and the ordinates is at x is equal to 1, and we have it at x is equal to what? 3, okay? So usually in the exam or in some exams, what happens is that you are expected to know how to sketch the curve. So I've done sketching in previous videos, how to sketch a quadratic equation how to sketch a cubic rational. So you can go back and have a look at that. So, but for the examples I'm going to be using, I'm going to give the curves itself. All right. So in some exams, you're expected to know how to sketch the curve first before you find the area. In some of them, they'll give you the curve for you to solve. So to be on the safe side, make sure you know how to sketch curves. So let's assume this is the curve for this. Right, so we have this curve here. So we're told that the x-axis is between what? 1. So this is 1 here. And this is what? 3. Let's assume 3 is here. So the exam, the question here, they want you to find the area under the curve. So remember I said in the first slide is that if the area is under the curve or the line to the x-axis. So in this case now, it's going to be under this curve all the way to the what? To the x-axis. So it's going to be, all the way, because between 1 and 3, so it's going to give us all the way from there, all the way to the x-axis. So that's what we are looking for. So the question is asking you, what will be the area covered by this part? All right. So now let's get cracking then. Now let's look at this. So we're told that the area must be what? Positive. So the area must be positive. So let's look at this. So that's step 1. So step 1, we're told the area must be positive. So the area must be positive. So what we are done solving, we cannot have a negative answer. And even though we have a negative answer, what do? We ignore the negative sign. So step 1 is that is done. Now step 2, we're going to step 2 now. Now, what is the step in step 2 now? So step 2 said that we then have to integrate the function as normal using any of the previously discussed rules, okay? So if, for instance, we were given this integral value, how would you have integrated it before? So let's go. So we're having 4x squared. So that means this curve is called y is equal to 4x squared plus 7x plus 9. So that is the curve, right? Okay, so we're meant to integrate this. So we're having 4x squared plus 7x plus 9. All right, so as you all know already, the upper limit here is 3, and the lower limit here is what? 1. So we're going to integrate this. So like I said, we'll apply the rules of integration. So if you don't know how to integrate, please, this is a good chance for you to pause this video, go back and look at the 15 or the 16 rules of integration. Make sure you know how to do it. So when you integrate this, you're going to add 1 to the power. So it's going to give us 4x raised to the power 3 divided by 3. So add 1 to the power divided by the new power, plus we're going to have 7x raised to the power 2. You add 1 to, because remember I told you there's an invisible 1 there. So 1 plus 1 will give you 2 divided by 2. And when you integrate a constant, it's going to give us 9x all the way through 3 and 1. Easy. All right. So we've talked about this, so I'm not going to spend so much time on this. So please go back and have a look again. Step 3. So step 3, we're told now to substitute the upper limit into the integral expression from step 2, and we're going to have a result. We'll call it y1. So the upper limit is 3. So basically, anywhere you see 3, all right? Anywhere you see x, you substitute 3. So it's going to become 4 into bracket 3 cubed over 3, all right? Plus 7, 3 squared over 2 plus 9, 3. And what would this give you? When you press your calculator, I think it's around 189 divided by 2. And this is equal to what? y1. So for this now, we can now say that for this example, that the y1 is equal to what? 189 divided by 2. Okay? So therefore, y1 is equal to 189 divided by 2. Now, step 4, we're going to repeat the same thing, but in this case, instead of us substituting the upper limit, what are we going to substitute? We're going to substitute the lower limit in this case. So anywhere you see x, you're going to put 1 now. So let's solve this together. So it's going to give us 4 into bracket 1 raised to the power 3 divided by 3 plus 7, 1 raised to the power 2 divided by 2 plus 9, 1. And when you do this, it's going to give us 83 divided by what? 6. And this is going to be equal to the y2. So therefore, the y2 is going to be what? 83 divided by what? 6. The y2, write it better. So the y2 is going to become 83 divided by 6. Now, step 5. What does step 5 say? Step 5 said that what we need to do, we need to subtract the lower limit into the, we need to subtract step 4 from step 3 to give the area. So that means basically we're going to do y1 minus y2, all right? y1 minus y2. So let's go back. So step 5. Step 5. So step 5, we're told is going to be y1 minus y2. So basically, the upper limit minus the lower limit. So the upper limit we have was 189 divided by 2 minus 83 divided by 6. So basically, you just put in your calculator, and I believe this is going to give us 242 divided by 3 units square. Okay? So this is unit square. So any unit they gave you, if it's centimeter, it does not really matter. That would be that for that. All right, and that is that for how to find the area under the curve. So basically what you do, because basically you will just integrate this between the upper limit and the lower limit. And you always know that the integration is going to be always, the area is going to always be positive. Then when you're done with that, the next thing is that you integrate it as normal using the 16 rules. And when you're done integrating, you substitute the upper limit to get a y1, you substitute the lower limit to get a y2, then you subtract y1 from y2 to give you the area. And the area must always be positive. All right, in the next video, we're going to solve more questions. And I'll solve more questions on the area entirely above the x-axis. So just make sure you subscribe and click the notification bell. So when I post a new video on the above the x-axis, more examples so that we can solve it together. All right. Thank you very much. So I'm going to see you in the next video. And don't forget to always like, share, and subscribe, and click the notification bell. And also, if you have any question, feel free to send me an email and I will respond as quick as I can. All right. Thank you very much, and I'll see you in the next video. See you soon.